All right. I record these, so hopefully that's okay. It's just an awkward, yeah. They all have 3 views, so it's not exactly popular YouTube, but important nonetheless for making sure people can view the archives just in case they want to. So typically in these meetings, we talk about what we're most excited about, what we're least excited about, and what's coming up. I think I know those things about you from you guys. So the other topic I wanted to talk about is activity development for 2019. So currently we're doing a flu shot for the winter activity, which will be the last kit of 2018. And we have some ideas for 2019, but it's important to me that we do activities that work for everyone and that are topics that people are interested in. So what kind of things would you like to do activities on?
I don't know. That's I feel like I've been thinking so much about what we are doing that I haven't had a lot of time to think about like what we should do, you know? Like I'm still getting up to current.
Okay. So this is a question that I ask non-graduate students. What got you, so you decided to major in science, both of you, as an undergrad, and then go on to graduate school. So it's probably not your specific dissertation topic that made you super interested in science. So what was it that you were like, oh, this is really cool. I want to do this?
This like so far removed from that decision now. I mean, I was always interested in how like things interacted with each other. So that does actually relate to mine. It's like, I don't know, how behavior influences other like species working together or shared environment, how that relates to each other.
Oh yeah.
That makes sense.
So like either doing an evolution of behavior activity or doing something about symbiosis sort of thing.
Definitely interesting.
I think an evolution of behavior one, I mean, we could pull from evolutionary biology, but we could also talk about, we could also bring in, there are people in our office who have psychology backgrounds, and we might be able to kind of, because people really care about human behavior and like where it came from. So that might be fun. And symbiosis is always cool. What about you, Elaine?
Maybe mine's similar in a way. It like kind of the complexity of interactions, like how things can be so specific and so general at the same time. I think it's cool, like kind of like trophic level interactions.
So emergent properties of like scale or I mean, we could, like, I'm just trying to think of like, yeah, I guess you could do, I mean, you could do things about climate change that look at different scales, or you could do things about evolutionary biology. You could do things about evolutionary constraints. You could do something about like modularity and integration. Like there are a lot of kind of really current topics that could address. Cool. Any other things that like when you do activities people ask you questions about?
Trying to think. I think a lot of people, I feel like always ask, this apply, like how does this connect to what really happens, you know, or like, oh, we see how you do the DNA extraction or whatever. What is this, like, how does this connect to kind of what scientists are really doing? So I just wonder if there's other topics where people maybe see what the science says, but it's kind of, there's like kind of a disconnect between what that means on a more physical interactive level. I don't have a good idea of like a topic in which that's true, but if there's things that are kind of popular news science topics or something, I don't know.
Are you getting at the issue that people sometimes feel like you're kind of and not you in particular, but I experience a lot myself, where people feel like you're being a little bit patronizing and you're doing like an oversimplified version of the experiment, and they want to actually feel like they are doing the cutting edge science, not the kind of basic level stuff?
I'm thinking a little bit more about how some of these activities we kind of like have this simulation, you know, like let's say DNA extraction or whatever. We do it, you end up with goop in a tube. How does that connect with, you know, how do you kind of like take that and go to these next steps? I feel like that's a question that
there's been a lot of questions about how you like read the DNA. So a lot of people are like, do you just get a really big like microscope and like zoom in and look at it? And that's not the case. But like there's been a few people asking how you actually then get to like, I guess, like read or see what the DNA actually is, what the sequence is, and explaining sequencing to people is sometimes challenging.
Right. Yeah, no, that could be
how that process actually happened a few times.
So is there kind of an add-on activity we could use for the DNA that would kind of allow them to at least understand some aspect of, and it may not be like genome sequencing, but some aspect of kind of going from goop in a tube to like, what does that goop tell us?
Yeah, I wonder if that's just kind of a simulation of like, of not even thinking about like Sanger sequencing, but like zooming in on the DNA and then looking at the nucleotides, and that kind of translates into that kind of like coding part that we talked about developing in the beginning or something like that.
Yeah, so like,
I don't know.
I mean, it's like, I know it's 15 years out of date, but I mean, you could do something with like, you could have fake PCR, where you can have them like go in and like physically cut with scissors at every time they see different, you know, you can basically have them use scissors as the restriction enzyme and then like lay it out on a gel and then decode that gel. I mean, it's not really what we're doing, like no actual, well, I guess I've seen some talks with PCR and gels, but I know it's kind of out of date, but it might be a little bit more directly related. But I think I think you're right that between step A, which is goop in a tube, and step C, which is, you know, actually figuring out what it means, we might want to go through and talk about nucleotides. And like, you know, actually not just go from here's some random letters, and they correspond to the goop in the tube, but actually put that information in.
Yeah, like that's just something that seems to come up a lot, is that we kind of try to connect it to what scientists are really doing, and sometimes that comes up with questions that are hard to explain without visuals, or it's kind of a piece that sometimes gets missing. I don't know, so I was just trying to think of like other things where maybe there's a similar kind of interaction, like public interaction, where people hear about some concept, they see the news about the results. How can we kind of connect what, like, you know, what you could do at like when you stop by a booth and get through that process so people have like to change or like help people's understanding of how some scientific concept works on that level.
Yeah.
I don't know, but I don't know. I don't have like oh, of course, it's this.
Yeah.
I don't know.
Also, coming off of that, I feel like when we've done this DNA extraction, I feel like there's this like idea of like what you can use DNA for, what it can tell us, and going like much more the Jurassic Park route, and kind of thinking like, oh, we can just recreate organisms in the lab. So I think like what limitations and expectations we can in reality can learn from DNA, or the idea like, I don't know, I just feel like there's been some like, oh, then we can make us like smarter or like change things. Like, I don't know, but there are some things we can. I think like the realm of where science is at with what you can do with DNA and what it can tell us is not always like, I guess, well understood. I feel like we see these shows, if you ever watch like a crime show where it's like, oh, and they take it back to the lab and
Yep. No.
whatever can it tell us really.
Yeah. No, I think that's a really good point. And I think like creating the space to be able to have those conversations and creating the language to, because you wanna make sure that you are not discouraging their curiosity, but at the same time you want to, you want to let them understand that yes, all of the kind of questions and confusions that you have about like what science can do, scientists actually have that too. Like there's a lot of error in those estimations sometimes. Yeah, so I think figuring out a way to kind of facilitate those conversations would be really good. But I'm not sure if it's like, I don't know if it would be a great activity, because I don't know if the scope of the activity needs to be what science can't tell us, because I feel like that's kind of depressing a little bit. There's probably a way to do it.
I think it would be like a fine line of like, it'd be tough because it's a fine line where you don't want to be like, well, we can't never know this, or like, don't believe anything you see.
Right.
Yeah, things we never helps.
The framework I always use is encouraging skepticism without cynicism. Mm-hmm. So you don't want naivety, but you also don't want cynicism. So like keeping people in that like healthy skepticism realm is fairly difficult, but that's, yeah, you want to have them questioning without just denying. Cool. So is there, kind of going back to Elaine's point about ripping things from the headlines, what do you think are the biggest, like what do you find interesting, or what do you think people who are going to be in your communities might find interesting that they've read about in the headlines?
I think we're doing a good job right now of hitting on some of those big concepts. Like we just did flooding, flu virus is coming. Yeah. I was thinking about things like that, Zika virus. Mm-hmm. Not that that's a thing here though, necessarily. There's that tick one that was fairly recent. I'm trying to think of like what else is. What about all these the red tides and the algal blooms and things like that are.
So I'm actually developing an evolution of bioluminescence one that is working with the algae that is found in red tide.
Cool.
So in Oakland, we're doing a bunch of outreach at like a light festival where it's all outdoor activities in the dark with lots of light. So we're doing bioluminescence, and red tide is the climate change tie-in, and also evolution. So it's a great idea, and if you're interested in beta testing the kit, let me know.
Yeah, like around here we're seeing a lot of the, you can't swim in this lake because it's too dangerous and that kind of thing.
Yeah.
So maybe a good like, summer 2019 kind of activity.
Yeah. It's a problem. I say this having lived on the West Coast for 2 months now, but it appears to be a problem out here. So, yeah, I will have that kit ready to go, and if you guys are interested, you can definitely take part in testing it, or I don't think it will be one for national distribution, but if you're interested, you can have it. Because I think it's part of it is actually having a place to store the algae. Like, you have to grow the algae. And so I think that's a lot to ask for volunteers, but it seems like something that you could easily do in a lab space. So
yeah. Interesting. Yeah, we'll have to look and see if there's kind of a relevant venue for that kind of activity.
Yeah. I think human health and disease is definitely something that people care about, and it's a hard one to do because you don't want to veer off into offering medical advice, but I wonder if there's a human health related activity that might be, or something, a human health concern that might be fun to address from an evolutionary perspective.
I thought the evolution of running thing was kind of cool. I know it's a little off in terms of like human health, but it could connect to that kind of realm.
Yeah, we can. I mean, you can definitely tie it into health, but it's there are some options with the evolution of running. Are there any other, especially if it's not a kit for national distribution, which spoiler alert, I just had my quarterly check-in with Anne, and we've decided to kind of to spend 2019 developing 10 to 15 new activities. So there are going to be a lot of activities that are being developed and being beta tested. So there are a lot of options, and the idea is to start with about 20 ideas, beta test them all, and then kind of see which ones have promise for national distribution, which kits have, which are fine, but maybe too specialist, and then which ones that are just,
cool.
So, are there any, do you ever have conversations about human health when you do these interactions with people?
Not like so far with the activities that I've done, because I don't think they have lent themselves so much to human health. That's really the big thing.
Mm-hmm.
Yeah, I don't think I will home either.
Nothing other than like kids wanting to get like a pH of 12 because it made a green color, and me telling them we do not have that. It's dangerous. That's the only closest thing to like human health.
Yeah, no, that I'm glad that you're not able to make a pH of 12.
No.
Oh man.
Yeah, so
that's getting on for like dropping it on the table and no longer having a table.
It was more of like a mix of pretty color, and they wanted it to get to a pretty color.
So
we can move to the table.
We're gonna just move real quick.
Oh no, you're fine.
Sorry. Need to write a new Booster Club office into a grant someday. No, I'm just kidding, but
storage, everything.
I'm applying for a $10,000 grant from Iowa. It's due Monday. Otherwise, I would involve you guys in it. Ashley Collins just sent it to me.
Oh wow.
It's to fund, like, it's an incubator, but then it will fund kind of expansion activities. So I will get some staff money and some travel money in there for you guys, in addition to Booster Club activity kits. How do you feel about dissection?
That'd be fine.
Yeah.
Have you done dissection activities with people?
Not with young people. The lab that both of us have taught here has like 2 dissection labs, and it's pretty like not super heavy on like animal anatomy. It's like, oh, what are the similarities? And there's a range of like invertebrates and vertebrates. So a little bit, but that wasn't really like.
Was it heart, brain, eye? Like what kind of things?
It was like, let's look and see.
Like, you know,
organ systems, more of like what type of digestive system and different invertebrates, what type of like respiratory system, how are they doing these like very basic processes that all animals need to have. So it wasn't like an organ dissection, it was more of like full body. What
Okay.
is looking at?
Yeah, like comparing across different systems, like they'll have all the vertebrates on the same day, and so we look at how that differs in a lamprey versus a frog versus a pig, you know, that kind of thing.
And then also connect it to like their environment, what kind of like constraints do they have, like, I don't know, if you don't have fully developed lungs, that constricts like where you can live type things. Or like if you're going to live on land, then you're going to have different things to allow you to live on land.
Okay.
So broad comparisons, I would say.
Okay. Cool. So you guys you're comfortable teaching, you're comfortable doing dissection-y things, and you like it, kind of?
Yeah.
They're fine.
Always a fun day.
Okay. Okay. Hearts are cheap. Hearts are really cheap. Like, you know, the preservative ones. I think you would have to, like, experiments with hearts are kind of weird, but you can do them. So it's not, you can't just like I'm gonna dissect a heart and tell you about it. You want to make it kind of an inquiry-based activity. But yeah, hearts are fun. It's better when they have the lungs attached, because then you can inflate the lungs and like feel them. But lungs, like hearts and lungs degrade really quickly. Hearts you can keep in a bucket for like years and nothing happens to them.
Sweet.
Yeah. So yeah, maybe heart disease and some sort of heart thing. I don't know. I'm in a gathering phase.
Yeah. Is there something about kind of the evolution of the different developing multiple chambers, like going from 2 to 3 to 4 or whatever? I don't know anything about the history of that change, but if there's something of interest that
I think, you know, the 2 to 3 evolution was a big deal, and then no one has ever actually given me a definitive answer. I mean, obviously you don't want deoxygenated and oxygenated blood in your ventricle, but there's not really if that's the answer, it's kind of boring for why you go to 4 chambers. But yeah, I think something with the evolution of hearts. NCSE used to have like half of, well, I mean, you've seen our bumper stickers. We have the like, yeah. So yeah, something with hearts might be fun. And you could, I mean, the idea would be, it would be great to be flexible. So if you did have someone who wanted to come up and have a conversation with you about heart disease, or like their grandmother's like heart, and like, oh, I want to see, like, she had a mitral valve prolapse. I don't know what that is. Can you point it out? But then if you also wanted to have evolution.
Yeah, that would be good, assuming we can be good enough at our anatomy to be able to like point out those features, which I'm sure just a good key and a good specimen makes it not that hard.
I think I don't know the exact keywords, but there are plenty of YouTube videos of heart dissections, and the last time someone found it, there was one of me doing it like 4 years ago in a lab. So yes, heart dissection videos are abundant. But yeah, they're once you know it, it's pretty easy to find stuff. But it's just, I want to make sure it's inquiry based. Like, I want to make sure that they are asking a question to find out an answer, instead of just like, let me tell you about the heart.
Yeah.
So there are options, and I wish brains were cooler, but like brains are so lame to dissect. Like, you get really excited, and then you realize that all the parts of the brain that are cool are the parts that you don't actually experience in the dissection of the brain. But I will keep thinking about kind of elements that allow for dissection. So we can, I don't think, Anna's not gonna make it. There's another Anna.
Well, that's
Okay. I'm not completely out of it today. Anything from your events? I know we talked about it last Thursday, but
like how they went, or
what you're feeling about them? Anything?
I feel like they went well. I just need to. I think it was nice because it was already like a scheduled event that the library had, so people were most likely going to show up. And I feel like the people that showed up were really interested in it. The one downside to that is you're not getting people that are just like wandering by. And so like definitely less people. It was still fun, and I thought it was a good like 2 events. I like the older kids. I think our activities are like a little bit better at the older age group that they had. They had a younger age group the first day or the first activity. And I think that group might just be like borderline a little too young for a lot of our activities. Or I think a lot of it is just going to go like this, and especially for that long of an event too.
Yeah. Don't feel so. Like, I'm really glad that you felt like they went well, and I'm sure they did. And also, like, keep in mind that these are your first events that you're headed by yourself. So, like, the fact that you are feeling positively about them means that they probably went really well. I was expecting you to be like, oh man.
There were like moments with the first one where like Betty, the librarian who was there, was super helpful because like the kids were just like all over, and she kind of helped focus them. But after the second event, I had like 2 parents afterwards who were like, oh, thank you so much. I like learned something new too that had like stuck around. And so they were asking more questions about like where I was from and stuff like that, and were interested in like knowing more. So I felt like those interactions with the adults also went well, that hung out at these events who weren't as hand-on in the activity, but were like in the room while their kid was doing the activity. They seemed to be also well engaged.
Oh, that's awesome. And you know, you are not responsible. I know you're not supposed to know how to magically make children respond to your commands. That is a skill. So, you know, that may be one of the many skills you develop by doing a booster club, but don't, you have been in grad school, and of course you won't know how to make 5-year-olds and 6-year-olds behave. So it's not, you're gonna learn, and you're gonna get better at it, and like, it will be fine. Feel free to bring feel free to turn STEM into STEAM.
Mm-hmm.
Bringing an art activity that is related, it's a good way to kind of, toward the end of the time, if you're working with little people again, and maybe you're like, I never want to work with little people again, and that's fine. But you can always have them, make something, take it home with them. That's kind of an extension activity. So for, just like spitballing for, ocean carbon crisis. Little kids get so distracted by stringing beads on a string. It is the greatest thing. You could have them make an ocean necklace where they put 5 blue beads and then a fish bead, like a pink bead, green bead. And they make an ocean necklace to take home with them.
Mm-hmm.
And it costs no money, but it means that they don't have to be focusing on you the entire time.
Right.
They can kind of, and little attention spans are little attention spans. So yeah, if that is a way to kind of make those activities work for you, use them. Cool. Do you feel like you ladies are spending, are you spending a lot of time on getting, how much preparation did you do for the activities?
I felt like I did, I don't know, like time-wise, because there's like a few nights where I was just like, I don't know how long. Mostly with like the first activity, the ocean crisis, I felt like I spent more time trying to figure out the best way to use the cabbage juice powder, like what would be like the most like easiest way to test it, what would like show the colors the best, what things to use. So I think that one took probably more time, and that aspect of it was just like figuring that out, because I was more comfortable with like the blowing bubbles aspect of it, but it was the first part. So I think that was like, I don't know how long I spent at home fiddling with that, but definitely like more than an hour, but I would say less than like probably like 1 to 3 hours maybe. I can keep better track of this. The other one, probably somewhat similar, because I was trying to think of how to extend the DNA extraction. Like that part, I was like, I got this. And then a lot of like, how do I simplify this? Because I did do what you suggested, and I didn't end up having any PowerPoint slides. So I was just talking, and the room that we were in had a whiteboard. So for a few things, I was able to just like draw things out. And that helped for like when we got to the part in the DNA extraction where you have the 2 layers and the DNA is being pulled up, I was able to like draw that on the whiteboard and be like, don't mix these 2 layers when you're trying to do this. So it was easy to like show that with the whiteboard. So I didn't like have just slides lecture style, but then it's, I guess, sometimes just trying to figure out how I was going to tie these all together and how I wanted to like simplify the language. So I started with like, what are the topics I'm going to talk about? This is way too jargony. How can I make this more simple to like digest?
Great. Well, it sounds like you were it's really great that you managed to extend the DNA activity in like really interesting ways. And it's like, it did seem coherent as a like single story, even though there were 3 activities.
Yeah. And it seemed like they liked the beginning one with the cards because they were able to move it and talk with each other, and they were thinking that through. And then I think this ties into what you were saying earlier with like the art activity, the whole like decoding. They like really liked that, and all of them took home the little like sheet of the code, and a few of the girls were like, I'm going to write secret messages at home using this. And then one of them wanted to do like almost, when I walked into the room, the kids that got in there earlier were playing Hangman on the whiteboard. And so when they left, one of the girls was like, I want to do Hangman, but like use like DNA sequences and stuff. So they were getting into like that aspect of it.
So these were like 10 to 12-year-olds?
Oh, yeah, I think like the youngest might have been like 8 and the oldest was like 11.
Okay.
was around the range because they went around and introduced themselves and what some of them said like what grade and some said year. So I was kind of like averaging.
Okay. Yeah, no, I could definitely see like late elementary, middle school for into secret codes and
I mean, that's what I did in late elementary school, so.
same here. Yeah. Okay, well, that's great. And yeah, I'm gonna try and have a draft of the mystery like DNA extract. But I'll touch base with you and make sure that because I'd love to know exactly what you did because it sounded like it was a big success and it would be great.
Send you, well, one of the messages I wrote wrong, I mixed up a letter, and so then I just told them it was a mutation, and that happens.
Yeah.
Well, as they were doing it, I was like, that's not how you spell the word, and I looked it up, and I was like, I messed that up.
It's all good.
Yeah, so I just had like strips of paper. I didn't send what I printed out, and I had like 2 easier messages and 2 harder ones. They didn't go through all of them. It was just like to have. So I was also thinking if they get bored with this aspect, they can write their own and give it to someone else. And so I think one of them was like, apples have DNA, because we just did the applesauce activity. And another one was like, I can read DNA. I was like, that's good. And I think the other one was longer, was we are all scientists. You can spell that out with amino acids. And I forgot what the other one was off the top of my head. We didn't get.
Do you had them convert like the nucleotides into amino acids?
I'll send it to you. It was just a Word document where like the nucleotides were spaced in codons, and then I had a space underneath that for the letter. So it was like easily spaced.
Oh, that's smart.
So I made it like you didn't have to like separate that out. And then I just had one line underneath so you could clearly be like, this is where I put the letter that corresponds to these 3 nucleotides.
Okay.
Like that's visually easier to do.
That seems like, yeah, that's a good idea. I was trying to figure out how you used 4 letters to write messages, and now this makes a lot more sense. I thought they were like matching up like
No.
the strings. This makes a lot more sense.
Yeah. And I think the stop codons are like spaces, so then you would like leave that blank, so in between words you have like a spacer.
Okay, yeah.
Can or cannot use, and we just did not go into like reading frames or anything. It was already like in frame, space, easy to do.
Yeah, and you know, it's what those people walked away with. I assume they're mostly girls, but I also assume there were some guys.
Boys there too.
They all walked away with thinking it was really cool and thinking that they were able to use it, and that's so much more important than them having the exact knowledge about a codon. Like, they had this like wonderful positive experience with science, and they like made it applicable to their real life and thought it was cool.
Yeah.
And that's what we're all about.
And there was like one boy who had a little bit more trouble like sitting still and focusing, who like was really focused on this activity, who was able to go through it and wanted to do more.
Oh,
and so that was kind of cool to see, because he was having like, you know, just a little bit more angsty, needs to move around, and then like got really focused on this task.
Oh, awesome.
Yeah.
Awesome. That's all right. So it is 3:10, so we can leave it there. But thank you guys so much for the information. I will let you know how kit development goes, and I will chat with you actually next week this time.
All right.
Not in 6 hours. All right, sounds good.
See you later.